This week we're going to look at how to clean these messy polygons. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week we're going to look at the polygons that we got from the Aviation Weather Center last week and see how we can clean them up a little bit. Now the first order of business is to get fewer polygons on the map. This may not be the end goal, but let's get it to where we can actually see what problems we're having. So I'm going to go up into our make polygons for airmet sigmet function, and we're just going to filter down a little bit here. We're going to get the rows in our data frame where the data frame hazard type is equal to IFR. We could set any hazard here, but this one doesn't have that many polygons. So now if we look, we see we only have a handful of polygons, and it's pretty clear to me that there's an ordering issue here. We start going around the polygon, come back to this central point, go down, and go around. If we look at the current map, we see it should probably look something like this. So what we need to do is sort these in an order that's standard to most GIS polygons, which is counterclockwise. Clockwise would be a hole in a polygon. We've talked a little bit about polygon math before, but these are the general rules that you can go by. So we need to write a function to order points counterclockwise. So let's go up here, add a cell, and we're going to write a new function called OrderPoints. Our OrderPoints function is going to take points as an input. In our docstring, we're going to say OrderPoints in a counterclockwise way for polygons. First thing I'm going to do is make sure that whatever we pass is an array. We could be passing a list of lists or a list of tuples. We want to make sure it's an array, so all of our array math is going to work. Also, we need to make sure that we have NumPy imported. So I'm going to import NumPy as MP, rerun that cell. So now we've got our points. First thing we have to do computationally is find the center of these points. So we're going to compute center. This is just a mean of the x and y's. So center x, center y. I'm doing this on one line just because it makes a little more logical sense when I'm reading the code. Is the mean of points, all rows the 0th column, if you will. And np.mean points, all rows the 1th in the second dimension. Now we need to calculate the angle, a polar angle for these points. So what we're going to do is take the point, subtract the center, so now we have our polygon centered at the origin, and we're going to calculate what angle that makes, and remember mathematical polar angles are counterclockwise positive, which is convenient for us. So we're going to sort by angle to get our counterclockwise ordering. The polar angles for the points, we can use NumPy's arctan2 function. The first argument is going to be points, all the rows, the 1th thing, so these are our y points. And we're going to subtract center y. The second argument will be points, all the rows, the 0th elements in the first dimension, which is our x. And we're going to subtract center x. Now we're going to sort based on those polar angles. So I'm going to get some sort indices by using NumPy's argsort. Remember, argsort tells us the argument order, zero-based argument order, that is required to sort an array. So I want to sort polar angles and then use that order to sort our points. So I'm going to return points and use sort index to sort by that. So there's our function order points. Now we just have to use it. Here's where we're getting our Latin lawns. I'm going to make P the list of zipped lawns and lats. Then we're going to sort that list. So P is equal to order points of P. And finally, we create a polygon with those points P. So if we run our cells again, we now see that we have polygons that make sense. They don't have this odd jerking back to the start point behavior. Now, while most of these polygons do make sense, I have to admit that this polygon off the coast of California does not look like the depiction on the Aviation Weather Center website, and I have not yet been able to sort that out. So if we get that figured out, I'll update you in a future MetPy Monday. But I think this lesson on how to create an ordered counterclockwise polygon from some points that are not ordered is a generally pretty useful tool when you're working with GIS-like data, especially since a lot of our meteorological data isn't really provided in a traditional GIS format. I hope that you found this useful. I'll see you on next week's MetPy Monday.